Hello everyone, welcome to my YouTube channel Data Partnership. So this is continuation of my previous video on the playlist water security. So this is the second video in water security, what is water interventions to know the rainwater harvesting. So why it is important significance of rainwater harvesting is a critical water management practice, especially in the face of growing water stress, climate variability, and urbanization. We all know about this. Enhance water availability. So it can reduce dependency on piped and groundwater supply, especially in the water scarce regions. Reduce pressure on groundwater and urban water security, and it will support ecosystem recharge. Right, it can replenish aquifers. Climate resilience, it is a climate adapt we can use it as a climate adaptation tool, helping communities manage rainfall variability, dry spell, and uncertain monsoon patterns. The cost effective also, right? Why we are talking this? So because you can see this figure, the highlighted figure, water demand. We have water demand 634 BCM in 2000. Now it is 1093. So in next 5 year, 10 year, it is going to increase again. So that's why this rainwater potential is one of the factor to which can help us. So various government initiative by India. So in one of the point is that community driven model like rooftop harvesting and watershed program are gaining policy support. So government is also backing it up. So let's start and calculate the how rainwater potential, right? So in my previous video on this underwater security one, I have created a sample data called water use data. So this was the data like this. How we have taken some few sample household, how much daily water use, how much percentage of gray water they are having, treated for how much water, how much percentage of water they can reuse, household size, and rooftop area. So so that's why this already I have done. So I will continue. I will do continue. I will continue this notepad. So so please refer that video also. I will share in the description box. There may be some changes in the spelling and all that you can check by yourself. So so what we have done is we have opened this file and it is like this, and then we have calculated the gray water volume because we have given the percentage. So we have calculated in the potential gray water volume potential, then reuse potential, and then reuse potential monthly, reuse potential yearly. So then we have calculated how much gray water we are using annually, right? This is the potential, and this is how much we can. Is it now? So basically, it is the meter cube. It was in liter, and this is the meter cube. So gray water annual reuse. So I think this I have changed. Earlier it was only annual reuse. So this time I have make it more clear that this is gray water annual reuse, right? So this is here. So water cost saving is that this is per meter cube cost is 25 rupees. So DF is annual saving gray water equal to gray water and we calculate multiply with the water cost. So this is our water cost, and total saving is this one, and this one is the our summary of all the calculations. So this is the how we have plotted it, right? So now what we are going to do is we will start from there, from here. So we have some assumption that we have our rooftop area is already we have given this one column is there, and rainfall is 800 per year. Means this is the average annual average. So this is I have taken just take a sample. You can customize it based on the actual rainfall, because this average annual rainfall calculated from the daily data for the long term, right? So we have runoff coefficient is 0.85 and water cost is 25. Runoff coefficient is how much rainfall is having, how much is running off. So basically this is the standard one. So now I have calculated here that this is calculate rainwater harvesting is that we have rainfall, we have converted this rainfall is in mm, right? So now we have calculated in meter. So this is even then we have calculated rainwater harvesting potential. Rainwater harvesting million cube per meter cube per year. So this is the formula. Just I did the formula and it comes like this. So we have rainfall and then uh, rainfall in meter and then rainwater harvesting meter cube per year, right? Then now we are using the total reuse. So how to do that? The total reuse is basically annual reuse. So this annual reuse means this one. Annual reuse means this one, right? No, this meter cube, right? Sorry, this one is annual reuse. So we have this one and plus the DF we have rainwater harvesting per year. So run it. So this is our total reuse meter cube per year. This will be our total reuse, right? So now we can calculate the total saving. So how much we are saving? Saving equal to DF total reuse total reuse into water cost, because water cost we have defined here, right? So run it. So how much is coming? So will have now saving. So this is our savings. So you can see now. So if you want to um, we can summarize this. I will just write code. I will copy from here this summary, right? So we will some household we need gray water, basically gray water use means uh, gray water this one, yeah, right? And annual saving you can put here, right? Total reuse, yeah. Basically it's a summary. You can use whatever you want. And total reuse, right? And all depends, just delete it. Maybe something I missed. Yeah, right? So you can add or delete the columns from here. So the next thing is that what you can do is DF, you can export this file to Excel or whatever, right? Water reuse analysis, right? Analysis dot xlsx, right? And that's equal to false. Yeah. So it's done. You can see here in the folder called here you can see the water reuse analysis. This one, yeah. So you can see all the detail inside it, and you can plot here also. If you want to plot a Jupyter notebook, then you can. So I have already written this, so I will just copy from here to save the time. Household ID and what we can do is we can saving, means how much we are saving. So how much money they are saving each year. So yeah, yeah. So these are our savings. So if you use earlier this graph was only for the gray water, right? How much annual water you use. Now if you are including gray water plus rainwater, then you can see your saving is increasing. So this is one of the things I wanted to show you. I think it should be useful. You practice this on your actual data. This is the sample data, and use it for, and in future you can you can create dashboard also based on this analysis. So that your local community or local village panchayat every can use that how much water availability in the municipal area or village or in the watershed, right? So thank you guys. Thank you very much.